All right. Oh, can somebody crank the lights back up? Sweet. All right, I think you guys should know like GCF. All right. Let's do one quick problem. What you got, Jeff? Trying to be a W. I like it. All right, try to factor that problem for me. All right, so help me out. What comes out?
2x.
Yeah, you take the smallest number that goes in all three, or I mean the biggest. So it's GCF, greatest number, so 2. And then you actually take, that's why I was saying smallest, the smallest power, because this guy can give 3 x's, but this guy's like, so it's like the semi-nice tax man. It's not going to take more than you got, but sometimes he'll take everything you got, right? So you can only take 1 x. That's all that all 3 of them can give is 1 x. And then how many w's can take out? 3. Notice how I kind of offset that a little bit? Because sometimes when people write it here, they just kind of start going, they forget this poor dude. Right? So what's left here?
2x.
Yeah, 4 divided by 2 is 2. I had 3 x's, I took 1. So I got 2 left. I had 5 w's, I took 3. 2 left. That's exactly what you can say to yourself. Right? It'd be in your head, not on your breath on a test. It'd drive people crazy. 6. I had 2 x's, I took 1. I had 6 w's, I took 3. I like it. Then do I just stop? No, because that divided by itself is 1. If I didn't have that there, this can't be true, because when I multiply this, I don't get this whole thing. So another way to look at that is it's a placeholder for this. And then the inside here I can't do anything with. It's not in the right form for anything, so I'm done. It was just a GCF problem. I like it. Yes, sir.
So the first step here, identifying with the, or just reducing as much as you can from the beginning, each term.
It's really, the first step is all about this guy here. It's all about what number and what letters, how many of each can you take out of everybody. So you can't take a 4 out of everybody because he's only got a 2. So it's a
Right.
2 you can take out of everybody. He can give 3 x's, but you look for who can give the least because that's how much everybody can give, right? Does that make sense?
Yeah.
So then you can take 1 x out because everybody can give an x, and you can take 3 w's out because everybody can give 3 w's. So it's backwards from distribution. In fact, sometimes we'll teach this and we don't even tell you it's factoring. It's just undistributed. What must have been distributed was this, because that's what they all have. And that's how you check it, is you distribute that through and make sure you get back to where you were.
No, okay.
You have 6 for the second part of the equation. Where did you get the 6x from?
12 divided 2.
Oh.
And then I had 2 x's. I took an x, so I got 1 left. So you are dividing. Whatever you put out here, you're dividing it out. Because it's the opposite of distribution, which would be multiplying it in.
How would you know when to do the 3-term problem factoring versus the common greatest common?
You always do GCF first.
Okay.
If you can, you do it, because it makes it easier. So for example, let's see if you work. You work, sort of. If I had this problem, what you got, Jeff? I don't know, man. Yeah, sure. Is that gonna work? Ooh, make this 32, I think. Oh, make it a 40? Oh, shit. Let's think for a second. Trying to make it work. Make it a 160. There you go. Oh, so close. Now, some people would go 4 times negative 160, and I feel bad for those people because they skipped the most important step, which is GCF. Right? Is there a GCF? Yeah. What is it? 4. X squared. Party. Yeah, so just divide each thing by 4, right? You seriously, now watch, just in case anybody needs it, you totally could do this. You could figure out what comes out, and then you can write each thing over that, because you are dividing each thing by that. And then it just becomes, and so do you guys see what I'm doing? So if you figure out that comes out, write that over that, and then reduce this. And then you do that for each thing. I could do it here too. I could have put this over 4, over 4, over 4, and then reduced it. Because that's what I'm taking out of everybody. I'm dividing that out of everybody. I like it, maybe. Some of you guys look at me like, you're going to have to make something make sense. Say something makes sense. Just by the law of averages. Now, what do I do with this? Yeah, now this is like your, really like your traditional factoring problem, right? You need 2 numbers that multiply negative 40. Add to be negative 3. Now, does anything work?
Negative 8, positive 5.
Yeah, so negative 8, positive 5. Multiplies to be negative 40, adds to be negative 3. Is that cool? Now think about it. Do you guys remember why that's the step we take? But what's x squared? How do I break that up? X and x. So I just need these 2 numbers. Well, what are those 2 numbers going to do? When I multiply them, they become this. And where's the middle term come from? This added to this. So they got to add to be negative 3. I mean, that's why that's what we do. We look for numbers that multiply by the last dude, add to be the middle dude. Why? Because that's what would happen, right? That's it. That's why. So yeah, negative 8 and 5, multiply to negative 40, and add to be negative 3. You guys, how are we doing? Oh, yes.
Hey, I got for the top problem. Okay, so right here we're just doing the inverse of like the 2x to the second and the 2w to the second, right? That in the parentheses there.
Yeah.
Yeah, right there. When we divide, we're just gonna minus those. But do we pick those randomly or just because?
No. Well, yeah. 4 divided by 2 is 2. X cubed divided by x is x squared. W5 divided by w cubed. If I had 5 and I lose 3, I've got 2. Yeah. So it's got to be the only thing. There's only one thing that I can put here because it has to multiply by this to become that. So whenever I factor something, I'm just rewriting it in a different form. I can't make it something different. They have to be the same thing. So if I said factor 18 and you said 5 times 7, I'm like, what? It's got to become 18, whatever you tell me. Does that
Yeah, I mean,
And that's why that's the way to check factoring is to multiply back out. Make sure it actually becomes this. Yeah.
And for the second, why didn't you put the X outside of the parentheses?
Which one, sir?
For-
Oh, here.
Yeah.
Does everybody have an X that they can give?
Oh.
Nope. So you gotta be real careful about trying to make this a little too easy. I can't take an X out because he didn't have an X. So if I would have put an X here, it would have made no sense because when I distribute it, 4X times 40 would be 160X, and that's not what it is. I like it. So some of us get a little too optimistic. They're like, oh, this is easy. Take an X out, I just put it, I'm done. No. GCF means it has to be common. The C is common to everybody. Not common to random, common to everybody.
Is there a way to put it back up to 4 parentheses x squared minus 3x? Like, can you go backwards?
Of course. X times x, x squared.
Okay.
Negative 8x plus 5x is negative 3x.
Okay, got it.
And then negative 40x. So that's how you check it.
Okay.
And then you just read the 4, you get back to there, so that means you're right. As long as this becomes this, the work you did is correct.
Okay.
Now sometimes somebody will argue with me and say, well, when I multiply this out, it becomes that. I must be right, Jeff. I say, yeah, but you didn't go far enough. Right? Maybe. I know you guys wouldn't really cry too much if I lost my voice, but I don't think it's that. Oh, we're so sorry, Jeff. Bye. All right. So let's take a look real quick at squares and cubes, and then we'll move on to the next time. To be honest, when you first look at difference of squares, you can look at it the same way we looked at this. I need two numbers that multiply by negative 64 and add to be 0, because how many x's do I have? 0, right? So what two numbers multiply by negative 64 and add to be 0? Positive 8 and negative 8. But then we say, oh, there's a shortcut there. They're always going to have to be the same numbers, opposite signs, because they're supposed to cancel each other. So the only numbers that's to work with are square numbers. Because those are the only ones you can break down nice into integers. I like it. You guys sound decent with that? Yeah, so squares have got to be like easy as hell. Yes, ma'am.
So for the first problem, that's the answer?
This one?
Yeah.
Yes, total.
And how come we can't break that one down more because they're one?
So real quick, let me show you something. Do you notice how the very first thing we did on this problem was we cut that in half? And do you see how half of this matches up with what's in the middle? So if this was a fourth power, this better be a second power. This was a sixth power, this better be a third power, or else that means I can't factor it like this. Maybe I can factor it some different way. So this, in order for this to be factorable the way we want to try to do it, since this is x squared w squared, this would have to be xw. Is it xw? No. So I can't go further. It's not the right form to go further. Yes, sir?
And if it was an x cubed, when it, because you said if it was a x to the fourth.
Yeah, cube here would suck, because half of 3 is 1.5. We don't want to have no 1.5. It's not yet.
So
Technically, it should work. Whatever this is, if that's half of it, it should work. In fact, let me not even say it like that. Since somebody moaned over here, let's do that problem. No, I'm joking. All right. Now watch. All right. Everybody's got this here, right? Okay. I want you watch which one. X squared. You're not a good one. Minus. Ooh, look at you. X squared minus 3x minus 4. And we did that x minus 8, x plus 5. Is that cool? Okay. So if it was x to the fourth minus 3x squared minus 40, the only difference, see, the numbers don't give a shit. Do you understand what I'm saying? Numbers don't care. It's still going to be negative 8 and 5 that make 40 and make negative 3, right? Well, what's going to change? X to the fourth would be. So why does this work? Because the middle terms will become something x squared. So if there was an x here, I couldn't do it this way. Because you can't add x squares and make x out of it. I really want you with me here. If I'm going to cut this sucker in half, and then I'm going to combine those to make the middle term, well, then the middle term better be freaking half of that, so that it's like term. So that's what would come out of that. Please let that make sense. Do you see how they're almost the same? So one more before I get really freaky here. What about x to the 12th minus 3x to the 6th minus 40? Is that doable? Yes. How do you know? Because that is half of that. And we already know the numbers that work. So it would just be x6 minus 8, x6 plus 5. At least for a first step. Maybe there'll be more steps, but we'll stop right there. You guys see that? Now, is that cool?
Yep.
Okay, good. Yeah. That sound you make could go many ways. So what? Look, let's do this one. The one I said was really gross, but it really isn't. Is it doable? Become a 3. Yes, because the middle power is half the first power. How do you do it? You break this guy in half. What is x to the 1.5 times x to the 1.5? What do you do with the powers? You add them, you get 3. All right, that's why breaking them in half works. And of course, the numbers we already know, minus 8 plus 5. Minus 8 of these plus 5 of these is negative 3 of these. That's why the middle power has got to be half the first power, so that's where it actually comes from. So math is not a bunch of memorizing shit that doesn't make sense. That's not what it is. Math is saying why it makes sense, which makes memorization natural. Just, of course you're going to memorize because it makes sense. Okay. Where are we at? You're like, don't say that yet. I'm not there yet, Jeff. Like, all right. Okay. Now. All right. Now, let's come back to difference of squares real quick. Difference of squares or cubes, that's when you have two terms. It's going to be squares or cubes, if anything, or maybe GCF. So watch this. Let's do an easy one real quick. Y squared minus 100. Don't say anything about 50.
Plus 25 is 45.
No.
10.
10. I like it.
25 is high.
It's okay. It's okay. It's all right. It's no problem. Right? It's fine. We're humans. We make mistakes, right? But that's the idea. The idea is that y times y is y squared, 10 to the sine is 100. And then why is there no middle term? Because the middle terms frickin' cancel. That's why. All right, now watch this. This is the same exact problem. I claim that that's the same as that. They're the exact same problem. One just has a little more going on. So if you get what I'm saying, they are the same problem. I'm not saying that y equals 25 or any shit like that. I'm saying they are the same idea. They're the same problem. How many terms are here? 2. That's it. I got it. Why? Because terms are separated by plus and minus. That's a big S term minus a big S term compared to this, right? But still, there's still 2 terms being subtracted. It could only be a cubes or a squares. How do I tell the difference? Well, can I cut everything in half? Or can I cut everything in thirds? I can cut everything in half. Can't I?
Yeah.
All right, so is that hard? Is it hard to cut things in half? No. So this is not hard. Your brain goes, there's a lot of shit going on. I'm going to skip that and just pray he doesn't notice. Right? But you should just go, brain, shut this shit up. I mean, see, just cut things in half. That's what different squares is. That's why I call it a thank your favorite deity problem. No matter how much shit I throw in there, you just got to give yourself some more room. Cut this in half. Cut it in half. Not like 12.5. When I say cut it in half multiplicatively, right? So what's 25? 5. X to the 5th. Y to the 20. You put the same thing over there, because that's the other half, right? Minus plus. Cut that in half. 49 is 7. A. B to the half of 38. Half of 40 is, so half of 38 is 19. Okay. Plus 7A, B, 19. Same freaking idea. Did I have more to write? Yeah. Did I have more stuff to cut in half? Yeah. Is it hard? No. I'm not trying to make you feel bad if that looked difficult. I'm trying to make you see how it's not. There's two terms. It can only be squares or cubes if there's no GCF. So then you go, can I cut everything in half? Yes. Oh, then you do it. You cut everything in half. Minus plus. Done. Next. You guys see that? Maybe. Just because there's more shit here doesn't mean it's harder than this. There's just a little more to write. That's all. Right? Okay. It's not even that much? All right. Trust me. Okay. And then cubes we talked about earlier, but let's just see if you guys remember what we talked about for cubes. There's only a certain number of things that I could use here. Let me see if you guys can do this one. I like it. Is out of cubes. Everything has to be something you can cut in 3 parts. What's 125? 5. Right? 27. Okay, so try to do that one. Oh, okay. This shows up. Sweet. So 27W cubed, how do you break that up? Yeah, 3W, 3W, or 3W, you just have to remember those go together. 125Y cubed, 5Y, 5Y, 5Y. So what goes in the little dude?
3W minus 5Y.
Yeah, 3W minus 5Y. So those two 3Ws, what's 3W times 3W? 9W squared. It's got to go in the front, right? So it goes with this dude. So 9W squared. So far I got my 27W cubed. Yay! And what goes at the end?
20.
Yeah, this 25Y squared. So then I get my negative 125Y cubed. So I make the first thing happen, I make the last thing happen, and then I have the cleanup dude come in and clean up all the shit I don't want. 1 of each, 2 of each. Product in the middle was 3w times 5y. 15 wy. And what sign goes right here? Positive. Opposite of that dude, so it can be the cleanup dude. It's got to cancel shit, so it's got to be the opposite sign. Let that make sense. All right. So I think we'll talk about one more quick topic, and then we'll head out. We normally go till 11:15. So let's see. This idea, is there anything specific, you guys? Any specific topic from that handout we did, or before I have an idea of what to talk about? Okay. The next level after you learn factoring is how to use it to solve equations. So why does what we do work? So we saw one like this on the warm-up sheet. But if I had a problem like x, let's use the best one. Come here. X squared minus 11x plus 44 equals 0. No, Jeff. Let's make this 28. So if that wasn't there, solving this would be stupid easy. Is that cool to say? Subtract 28, divide by 9. And in fact, some of you guys try to still do that, even with this here. You like subtract x squared, subtract 28, divide by negative 11, then you say, I got x by itself, I'm done. But you don't have x by itself if it's on both sides. Doesn't make any sense, right? So when we hit, that is easy. That has to have something change. I have to have another method to use, and it's not always quadratic formula. What I do is, if I can break this down into something times something is 0, what's the only way that could be true? What's the only way to have something times something be 0? There's only a certain way to make that happen. One of the numbers has to be 0. That's the only way. Now, if I had a 4 here, something times something equals 4, does one of the numbers have to be 4? No. It could be 2 and 2, 4 and 1, 8 and 1/2, 400 and 1 over 100, right? There would be an infinite number of possibilities. So the only number I want on this side, when I have a higher power than 1 on my x, is 0. Because it's the only one that says, I know that one of them has to be 0. I can get a definite answer then. You guys, does this sound familiar, hopefully? Or does it make sense if it doesn't sound familiar? On the surface of it, does it make sense? The only way to make two numbers multiply 0, there's only one way. One of them's got to be 0. How do you factor this dude?
X minus 7.
So that means whatever this number is, either it is 0, that number has to be, if that number is 0, then of course this is 0. Because it's 0 times who gives a shit, right? Or that number has to be 0. That has to be true, right? One of them's got to be 0. Does that make sense by itself? I can't read you this. Either you're like, of course that makes sense. This is easy shit. Or you're like, but on the surface of it, if I rewrite this problem as a product, I can look at the equation in a different way. I can say, oh, whatever that number is, it's got to be 0, or that number's got to be 0. It's got to be true. One of them's got to be 0. So either x is 7 or x is 4. So a lot of you guys are able to just jump to there, but what you're really doing is this step in the middle. What did I get? Yeah, good. All right. And then you can check it by plugging those things in and make sure it equals 0. Sweet. Okay. I think that's enough for today. I think we'll head out just a bit early today. Don't get too used to that. I'm going to post the My Math Lab homework for those of you who are doing that. You desperately want to get in there and try some stuff out so you have some questions for tomorrow. I might bring some more factoring handouts because it sounds like maybe we need a little more intensive look and reminder of factoring. So I have some stuff left over from on Math 90 stuff. Yes.
And it went to the survey, correct?
Yeah, I'm going to send an email out to remind you guys about the survey. If you go to the website, the first link is the survey. If you could just do that for me. Yes, always. You can get as far ahead on that as you want to. That's why I give you the whole thing. Yeah.
This last semester